Okay, good morning everyone, and we are starting the second day of our conference. And today my session is again devoted to the Firebird replication, but it's a kind of a level up presentation as compared with the one I did yesterday. So we will be talking about the performance implications of replication, about some advanced techniques, some usage cases. Not all of them is available right now in Firebird 4 beta release. Some of them could be available in the final release, maybe in subsequent minor releases. This is why it's called in Firebird 4 and beyond, because as I said yesterday, replication is quite a complex framework that can be evolving with every Firebird version and get more and more features. First question is, what is the replication cost for you if you use synchronous or asynchronous replication? Of course, it adds additional overhead inside the engine. For asynchronous replication, it of course adds some additional disk I/O, and for synchronous mode, it also adds some network round trips, and again disk I/O on this replica side, and so on. So of course, it's expected to work a little bit slower than without the replication enabled. But how much slower? Let's look at the numbers. I just used two different tests. One test is a kind of bulk loading, when 4 concurrent connections inserting a lot of records into different tables. And the second test is just typical old LTP load. Very short, small transactions, but 100 concurrent connections. Let's start with the first test, data load test. This graph shows number of seconds to execute the operation, so actually the less is the better. To have some starting point to compare the replication overhead, let's look at two numbers. The database running with forced writes on and off. Of course, forced writes, disabled forced writes mean actually almost zero or actually delayed disk I/O. So disk is not a bottleneck, it's just showing the maximum possible performance of the Firebird engine. But you know that it's not reliable, so we never recommend that. It's just a starting point, something, the baseline for comparison. And with forced writes turned on is the usual recommendation if you have, if you really need a reliable database. Of course, numbers are different. You can see almost a half slower with forced writes turned on. Forced writes turned on, yes. So here is the starting point. What if we set up synchronous replication? Yes, again we see that it's slower. Again, about 50% slower. Why? Well, we have to commit your data on the primary side, transfer the changes to the replica side, and commit them there as well. So actually the I/O is doubled on the master side, on the replica side. But as you see, the difference is not twice, it's smaller. Because of the way the replication protocol is implemented and optimized to reduce different overheads and so on. So the difference is significant, but not twice. Let's look at the asynchronous replication. Here we see that it's much faster than synchronous and almost the same performance as without replication at all. We are considering here forced writes turned on. So yes, it's a little bit smaller because the server writes to the journal files, but we are speaking about bulk data load. I was speaking yesterday about the caching of replicated changes per transaction. So actually, all the changes are cached and only then merged into the journal files in big chunks. We have only 4 concurrent loaders, so there is not really a lot of concurrency. So there is no bottleneck in the journal files. This is why you see that in this particular usage case, asynchronous replication works almost as fast as without replication. So it adds very, very little overhead. The synchronous replication adds more overhead, but again, not that big as some of you could expect. Not twice bigger, just 50% bigger. Okay, but let's consider a different use case. If you turn forced writes off for your master database, but keep it on the replica side. And here we see interesting picture. Performance is almost the same as with Firebird running without replication at all and with forced writes turned off. It's really fast, almost the maximum possible performance. But at the same time, you have a guarantee in the case of crash, because you have a replica database up to date. So actually, you can execute quite you can run your production system quite faster, but without losing their reliability. Or, of course, relaxing the reliability if you use asynchronous application. Of course, it's not an absolute guarantee. Some data lag still exists, replication lag exists. But anyway, something to consider. And the different test case, OLTP. Here the difference between the forced writes on and off is way, way bigger. Actually, here we see transactions per second, so the more is the better now. In this graph, it's reversed. So with forced writes turned off, the performance is 10 times, almost 10 times faster. But again, it's not reliable at all, you know. This is the difference in the OLTP case when we have a lot of I/O operations on the database file. The difference is especially noticeable if you run, for example, a database on Linux with the barriers turned on for your partition. So it's really can really be seen the difference of 10 times. So can replication how can replication affect this usage case? Again, we are starting with the forced writes turned on and then add replication. Here we see that synchronous replication and asynchronous replication does not really improve anything. But again, the asynchronous replication is almost the same in performance. The drop is very little. And the synchronous replication is again about 50% slower. So far, everything looks the same way as we have with the previous usage case. So far, so good. So far, it can be explained because we are still running the master database in the synchronous mode, forced writes turned on, and the same is applied to the replica database. Now switch off forced writes on the primary database. Again, as in the previous case, performance increase. Again, you now have some kind of safety with your replica. But here we see that synchronous replication really improves situation much better than the asynchronous one. Why? For the data load case, it was the opposite situation. Now we see that synchronous replication starts to win. What happens? A lot of small transactions, 100 concurrent transactions, permanently changing the database, right into the database. Replication level caching almost doesn't work. The buffer is never filled. It just contains 100 of bytes being immediately merged to the journal file. So we have a lot of disk I/O to the journal, a lot of concurrency because the journal file is just a single file. Well, actually, we have segments, but they are written sequentially. So here we see that in this kind of load, the journal becomes a bottleneck. And this is why the synchronous replication wins, because the transaction still absolutely independent, and the only bottleneck here becomes the database file itself on the replica side, but it's cached, so the effects are minimized. Can we really achieve anything with that? Can we improve with that? Yes, actually. These graphs based on the performance numbers I did 2 years ago. But after that, we have implemented the feature called as group commit for the journal files, which actually introduce some kind of artificial delay, but allows to merge multiple concurrent blocks together with one disk I/O operation. And this feature actually is expected to improve this particular situation and bring the asynchronous replication almost at the same performance level as the synchronous one. This feature is committed in the Firebird beta 1. It's available. It can be, by default, it's disabled, but you can set up to minimize the overhead, the concurrency overhead, and this bottleneck on the journal files. What we can do with that in practice? You know, maybe you don't know, there is an old trick with database shadow files. When the shadow files is kind of physical copy, synchronous physical copy of your database. But the problem is that it uses that shadow copy, uses exactly the same forced write modes as the master database, the primary database copy. If they both with forced write turned on, it means that every write is twice as slower, because every page is written to the primary database and then to the shadow database, synchronously, in the blocking mode. But if you turn your database into the forced write turned off, then you lose the entire guarantee of data recovery, because both the primary database and the shadow database will be written in the asynchronous mode without any guarantees of the cache being flushed or not. So in the case of some kind of power failure or something like that, you may get both copies damaged. So it's not work as a really reliable shadowing solution. However, there is an old trick to disable forced writes at the database level, but enable synchronous writes at the mounting level. Just mount the shadowing partition with the sync option on Linux, and it will be written synchronously in the blocking mode. So actually, the primary database is written asynchronously, the shadow copy is written synchronously. So the performance overhead is still a little bigger than without the shadow, but much less than twice. At the same time, you have your shadow copy always consistent and can be used for recovery. Well, yeah, I know that not many people use shadows at all. It's a very outdated feature, and we don't really recommend using it in production, but I know somebody does. But this exactly idea can be used with replication as well. Just disable forced writes on the primary side and enable it on the replica side. And set up either synchronous or asynchronous replication, and you can see that you can get the performance around the half of the case with the disabled forced writes, which is not reliable. But here you have a reliable copy and improved performance. A few times improved performance. What is the bottleneck? Of course, to get the maximum possible performance, you need to set up replication locally onto the same server. But you lose, of course, the reliability. If you set up a different server for replica, that's good, but you need to ensure really fast network connection and so on. And of course, it means that your regular database must be mirrored. So you need to have a copy to set this up. Really, again, something really may be specific and not usual and kind of weird setup, but in some cases it may allow you to improve performance based on replication. Of course, it's maybe not a solution for those running a terabyte database, yes, but if your database is quite small and you experience performance problems, but you do not want to disable forced writes for your database, it could be an option for you to improve the performance and still have some chances to fall back to your replica database in case of any problem. Again, a few words about different modes of the replica database. Yesterday I was talking about read-only replicas and read-write replicas. Read-only replicas is the primary application, and of course the one we had in mind while developing this feature is a standby solution failover solution to be able to just immediately switch to your replica database in the case of any failure of your primary database. Just a failover. To achieve that and to guarantee that the replication works smoothly and without any conflicts, you should really not try load balancing and using the replica database for reading. As I said before, if DDL operations are being replicated and may cause conflicts if you have read operations, read transactions against your replica database. So if your primary goal is to keep the absolutely reliable backup copy, to switch to them in the failover, then you should not consider any kind of read operations on your replica database, or just minimize them. It's allowed, but you should understand that it may cause conflict, it may block replication, and in the end you may get a replica not really up to date. But if it's really not your major concern, or if you have different replicas set up, you actually may use the read-only running read-only queries, selects any stored procedures involving temporary tables, because they are not replicated. You can really modify them inside the replica database. It's allowed in read-only transactions. So actually you use replica for the load balancing, for running some long-running reports, complex or analytic queries, and so on. That's good. And finally, you may use replica database to just make regularly backup without affecting performance on the primary side. So the load is just moved from the primary node to your replica node, and again you just do backups daily, whatever. Now, if you have set up your replica to be read-write, why? As I said yesterday, there are some cases when you run reports running not real temporary tables by kind of emulated temporary tables. So persistent tables, but just they are being inserted into and cleaned up and so on. You just need to understand that if changes in these pseudo-temporary tables are not really conflicting on the master side and the replica side, it's perfectly allowed. If you want to run such kind of reports that modify some local tables, just switch your replica to the read-write mode, and that works. Another application is just to merge changes from different database. It's usually kind of transmitting some batches of changes from head office to the branches, or vice versa, and so on. What you need to do to avoid any kind of conflicts. For the case with reports, modifying temporary tables just enough to exclude them from the replication set of the master side. So they are not replicated, so the changes cannot conflict at all. You just run your queries, reports with stored procedures, modifying something, deleting after that data, and it's not going to conflict with any replication stream transferred from the master side. Then you could somehow artificially ensure that the changes on the replica database just does not intersect with changes in the master database. It's up to you how to decide that. It depends actually of your logic. So some operations that are not conflicting by their nature can still be performed on the replica database. You just should know that if you do that, your replica database gets out of sync with the master one. If it's okay for you, if these tables that you modify on the replica side are not really needed for consistency, for recovery purposes and so on, it's allowed. And another thing is that if you do some changes but that are potentially conflicting, but you do not want to get any conflicts actually, you should ensure how to use some kind of global unique scheme for your records. I will be speaking about that later. So that the record could be uniquely identified from both the replica side and from the master side. Another thing you may consider setting up is a mixed synchronous and asynchronous replication. They are not actually some kind of, they are really absolutely independent and can be set up together. So you may set up either asynchronous, synchronous, multiple synchronous replicas, or both asynchronous and synchronous replication. It's perfectly allowed. Why would you need that? The usual case is that you want you want to minimize the downtime to perform a failover. So you would prefer synchronous replication because it's always up to date. It doesn't need to catch up. You don't lose anything in the case of failure. That's good. You set up synchronous replication. Then you are not really sure whether your network is absolutely reliable or not. What to do if this synchronous database just gets somehow disconnected and it's not visible or not accessible from the primary side and so on. In this case, as I said yesterday, replication has been disabled. That's a problem. You may set up second, third, fourth synchronous replica and so on. One gets out, the others remain working. It still provides you absolutely up-to-date copy to failover. But what to do if all of them somehow gets out? The usual case is that some problems with, for example, network switch and something like that. Your local network just got out, and you cannot connect from your server from your local network, other nodes of your local network. But your server still runs, the disks are working, and incoming connections, it's even incoming user connections. In this case, if you set up a synchronous replication as well, it will be continue writing journal files. If they cannot be transmitted to the replica side due to the same reasons, network problems, for example, they will be just accumulated on the master node, collecting them, and once the issue is fixed, they will be transferred and applied to the replica database. So you still have a backup solution. So you're trying to achieve the maximum reliability. You want to minimize downtime, almost zero downtime to recovery to the synchronous replica. But just in case it doesn't work for any reasons, 1, 2, 3 replicas doesn't work, you still have a journal file to be applied and have a little bit out-of-date copy, but it still may be good for you to recover. Yes, in this particular case, you potentially may lose some recent changes because the replica is not catched up the primary side. But it's just the worst possible case. In other things, you expect the synchronous replication will work fine, and it's not will be necessary. This is just an option to ensure the minimal possible downtime. Another option is that you actually may set up synchronous replication for actually replication, but use the asynchronous journal for other purposes. You may implement hand-made point-in-time recovery using journal files. Just make regular, for example, daily or hourly and backup copies, and you just keep the whole history of the journal files. Then you just take one backup and apply the journals available after that, and you are almost kind of handmade, but still point-in-time recovery. Or you may use just the journal kind of audit log to analyze them later, what actually was changing inside the database. Well, you need to write some utility to parse these files, but it's still available, it's still option. The format is open, so it could still be used for that. Another thing, which is at the moment not implemented in Firebird 4, but we're considering that in future releases, is the concept of semi-synchronous application. Actually, this is available in MySQL, if you know that. They don't have native synchronous application, but they have something, different levels of semi-synchronous replication. What does it mean? You need to somehow relax synchronization requirements, so you allow to the replica side to lag a little bit, not as much as asynchronous replication, just a little bit, to improve your performance. But still be able to recover. If something bad happens and you need to fail over, you either consider that this lag is acceptable for you, or you choose some different options to avoid that situation, and we'll show what ways are possible. What is meant by semi-synchronous replication? Really synchronous means that we have transmitted changes to the replica side, then applied to the database. The data pages in the page cache are flushed to disk. The transaction is marked as committed on the replica side, then it's been committed on the master side. Absolutely, two-stage commit, yes? So it's absolutely reliable, it works, but it could be a little bit slow if you really need synchronous replication. And what are possible options used in other databases to improve this situation? It's they exactly create options for semi-synchronous replication. We may not wait for the final commit acknowledgement from the replica node, may really not wait for applying changes at all. We just transmitted them to the client side or replica side and allows the replica to process them in the background. But on the master side, we just commit the transaction and go on. So it adds some delay. Of course, in the case of failure, this small number of changes may be potentially lost, but usually this lag is smaller than with asynchronous replication because of just its nature. Another option used when semi-synchronous replication is used, how to guarantee the recovery, is to set up multiple semi-synchronous replicas and define a quorum threshold on the master side. How many replicas should give you acknowledgement before you consider the transaction on the primary side committed? If you have 5 replicas and set up that you need only 3 acknowledgement, that's good for you. You consider it's committed, you continue working. You hope that at least 3 of 5 replicas will be restorable. So actually, because the lag is very small and actually depends exactly only on that local particular server when it's going to flush changes from the page cache to the disk and so on, the reason, the inevitability that all 3, 4, 5 nodes will be failing the same way of the same operation are really small. So this kind of quorum threshold just ensures, not to the 100% of course, but some nines, 5 nines, 6 nines reliability. As I said, it's not available now, but it could be available in further Firebird releases. Another concept applied in replication could be used is so known as multi-source replication. So far we were speaking about one primary database, one replica database, or 2 replica databases, or 3 replica databases. But here we have multiple primary databases, and the changes are being applied to the single replica database. The architecture really supports that, because every database has a unique identifier, globally unique identifier. All the journal files keep the same identifier inside every journal file. So actually, if you have kind of maybe one directory with journals intermixed from different sources, Firebird is able to parse them properly and detect how many streams, incoming streams are there, and apply changes from these sources independently. So architecturally it's supported, it just Firebird 4 does not yet support it at the configuration level. So far we allow only one log source directory setting and one unique identifier to filter the streams. But in the future there will be multiple sources allowed. It's just a configuration change. The only trick here is to have some kind of reliability to guarantee that you really replicate changes from the database you need, and not by some some configuration problem, some DBA making some mistake and so on, that they put some other journals into the same directory, for example, that should not be replicated. To be able to avoid this situation, we also have an option to filter the incoming replication stream by the ID of the database, source database. Currently it's optional. With just one primary database, it's really not needed. But you may still use in Firebird 4 Beta 1, it's a different configuration option, exists for that, to specify the ID of that database. So the Firebird will be checking are the incoming replication stream packets really belong to that database or not, to avoid any unexpected problems. With multi-source replication, it becomes even more important to just avoid any mix-up of different unexpected files and so on. Maybe not really common usage case, but when I was presenting the first ideas about our application 1 or 2 years ago on seminars in Prague, in Germany, one of the users, I remember, asked about exactly that situation. So they have multiple branches. They need to replicate the changes to the head office. They have a really big database that accumulate all the changes from the branches and then run some analytics for the chief officers and something like that. This is exactly the usage case for this feature, multi-source replication. That was already said. The only problem here, new problem here is again, we are speaking about either non-intersecting operations or you need to provide some global identification scheme for records to avoid any conflicts possible. If, for example, these branches work with differently named tables, no conflicts at all. But if they use the same table names and the records need to merge together, of course, we need somehow to understand that two different branches cannot have different records defined by the same number, because it will be considered being the same record, and the merging will just really merge. Finally, in the replica side, there will be only one record. So you need somehow to distinguish records before you set up replication for this scheme. Another option is the cascaded replication. You just set up replica to also act as a primary database. So we have some primary database, all the changes have been replicated to the replica side, and then exactly at the same moment, they have been replicated further to some third database. Why it can be used and what are the possible problems here? For read-only replicas, it's actually just a different option to have multiple replicas available. You may set up the primary database to replicate to different sources, or you may replicate it to one source, but then set up cascaded way to the third server, fourth server. They're just not available from the primary server. So far, so good. You may also switch these databases to read-write mode and use the first one for immediate recovery, the second one for reporting, and so on. The first one may be made read-only, the second one is read-write, and so on. We support this option since the very beginning, because the Firebird replication.conf file contains exactly settings for both the primary side and the replica side inside the same block. You just define the database, where to replicate changes, and where to get changes from. If both are specified, it actually allows to use replica database as a primary database. So it's easy to set up, but currently not all changes are being replicated properly right now in the beta 1 release, but it will be fixed before the final release. One may think, if we set up a loop between these nodes, does it really become a multi-master replication? No, it's not. With cascaded replication, the replicated changes are being replicated further. With really bidirectional replication, the replicated changes are not replicated further. Only the local changes are replicated back. This is the key difference between these two modes. If we speak about bidirectional replication, it's a different kind of setup. Of course, it doesn't make sense at all to use read-only mode for that. We have read-write mode for the replica side at the starting point to implement bidirectional replication. As I said, again, an absolutely requirement become unique, global unique identification records. What are possible options? Use guide keys, range-based keys, composite keys. The composite key may contain just two segments. One is some kind of ID of your server. The second segment is just some sequential number. With a range-based key, you just set up some, for example, use begin data type. Split the whole numbering space of this data type to multiple ranges. If you have 2 or 3 or 4 servers for application now, just reserve some space for the future. Say, okay, 16 maximum 16. So you would just divide your entire numbering space into 16 partitions and change your sequence generation for your primary keys to choose just some numbers from your local partition. Not globally sequentially, but just from your local partition. Or just use guide keys, but, well, it's the easiest solution, of course. It doesn't require you changing almost nothing besides the data types, and getting these values rather than gen ID, you use just gen UEID function. But global unique IDs, UUID types, is known to be really not that fast if used in indexes and especially in primary keys. They occupy much more space than any subsequently numbered data type because they are random. The prefix compression in indices doesn't work. So your indices become bigger, and you may easily, if you were running, for example, some big table with 3 levels of the index tree, the depth of the index tree is 3, and now it may become 4, and you get additional performance overhead and so on. So it's the easiest way, but it's probably the most slowest way. And if we speak about bidirectional replication, when different databases may modify independent roles, and they may modify the same roles independently, we need some kind of conflict resolution. Actually, what is kind of works out of the box with the bidirectional mode is synchronous replication, because every conflict is reported immediately. So if you step on somebody's toes, you get update conflict. But the problem is right now it will cause the replication to be disabled. It's not, of course, workable for if you need a really bidirectional replication. You just need to handle that conflict as a kind of local conflict. Just be able to roll back and recontinue. But with the asynchronous replication, things get even more problematic because you will be able to commit your changes on one database, it will be propagated to another one, when it may cause a conflict applying these changes because somebody else has already modified the same record. With one directional replication, with just a standby replication, we have simple rule to, well, the replication engine is ready, it can easily detect these conflicts if the record was modified, but with one directional mode, single directional mode, we can easily fix these conflicts automatically because we know that the primary database is a kind of, well, it should be the one who guarantees the consistency. So we can easily overwrite any changes in the replica database to prefer the master one, to synchronize the data automatically. It happens automatically in our replication engine. It just writes a warning in the replication log that some record seems to be conflicting and is being overwritten by the master changes. With bidirectional replication, it doesn't work. There should be clear rules which changes to consider good ones. There are different options for that. Usually, it could be some kind of global timestamp, which is synchronized between the servers. Who is the last one? He is the correct one? Yes. But in some cases, you may prefer that some node is actually more important than another one. So his changes should be preferred in this case. So these rules for conflict resolution should be somehow established and used. It cannot be done right now automatically. Well, it can be done automatically for the timestamp-based conflict resolution, but it may be harder to do that for the other nodes. Actually, here we need some kind of either manual intervention of the DBA to resolve these conflicts, or some kind of possible automatization to, for example, allow some hooks to call some external programs or libraries or batch files that may make such a decision. That they get different record versions from different servers, decide which one should be used as a final result. Here is, yes, delayed conflicts and manual resolution. Delayed because of the asynchronous replication, I mean, of course. Because they do not appear immediately. And another problem is how to replicate sequences. If you use them to generate some local numbers in one database and another database, the replication will just overwrite each other changes and the numbering will be broken in both databases. So the common solution is just to not use sequences at all and generate UIDs with the different schemes. Or we could use just somehow adapt the table filtering idea to just define that these particular sequences should not be replicated at all. We have not decided what to do with it yet, because this problem really exists in almost all replication engines I know, and different options are possible. To not use sequences is a common approach. It's the easiest ways for the replicator developers, of course. They do not change anything, they just require you to avoid sequences. But we could do something more clever, but we need to think more about that. And another usage case for replication is to simplify the migration. We said about that yesterday, and now I will explain in details. You have running Firebird 3, for example, in your production database, and you want to upgrade to Firebird 4. But you know that your database is 2 terabytes, so it takes 2 days to perform a backup or restore. Well, it's not really comfortable for you to have such a long downtime, and at the same time you want to test the new features with your real data. Well, you can do backup, restore, and test. But at the end of the testing, your database is not up to date anymore. You need to do the same, and so on and so on. Instead of that, you just set up replication. Here I suggest use asynchronous replication, because you just start that. It starts generating journal files. At the same time, you do backup, restore your database on Firebird 4. It gets new ODS. When it's ready, you set up it as a replica database and start collecting the generated journal files, applying them. It could be 2 days of backup restore. You have a 2-day delay of the replication lag. No problem at all. And the 3rd day, it will catch up. Now you have a consistent, almost up-to-date copy of your primary database, but running on Firebird 4. What to do then? You start testing on real live data. Of course, if you test read-only queries, it doesn't conflict anything, your replication is not broken. You want to run some OLTP tests, concurrent writes, and so on. Again, just switch your replica to the read-write mode and do that. The replication is likely to conflict and be temporarily disabled. You just do your tests, disconnect, and the replicator will again start working, catch up, overwriting your local changes. So you're testing it for 1 month, 2 months, 3 months, everything is okay. Now just promote your replica database to become the primary one. You may just redirect your user connections to the replica host, or just copy it back to the master side, install new Firebird version there, and so on. So it actually solves 2 goals at once. You have real data from your real production database that can be used for testing, and you have almost 0 downtime. You don't need to perform a backup restore to switch, because you had already done that before when you set up replication. Well, I know that it was actually a fantasy, because Firebird 3 doesn't have the replication, but it will be working starting with Firebird 4 to Firebird 5, Firebird 4 to whatever else like that, and so on. So this is actually what we suggest for migration, both because of the backup restore problems, because of possible incompatibilities, and so on. Again, if we just reverse this idea, we can also downgrade. So you just perform upgrade running Firebird 4 or 5 in production. It doesn't really matter whether you tried that to test and before, just risky guy and want to do it in production, put in production right now. But one day you may want to downgrade it, switch back. Just set up backward replication to the older Firebird version. In this particular case, it doesn't make any sense maybe to use asynchronous replication. Synchronous would be better because your replica database will be absolutely up to date, and you can downgrade immediately. But due to performance implications, you may still consider using a synchronous one. If synchronous works a little bit slower, your production server is just overloaded, it cannot afford more load. And again, if something bad happens, you use the same technique of promoting your replica database to become the master, and you switch back. Of course, it may not work if you had already adapted your application to use some new features of the new engine and so on. This is why, again, yesterday I suggest to switch first, test it first, and only after some time of stability, you just use new features from the new version. So this is also an option to how to downgrade without backup restore and without problems quite faster. And the final feature of our replication engine. So far I was talking that the replication is built into the engine and so on. This is actually the user point of view. Architecturally, it's not really so. The Firebird engine exposes some public interface that can be used for external libraries. It's known as CDC interface. CDC stands for custom data capture. So you may actually define your own, implement your own library that just being linked to that interface and gets all notifications from the server, from the Firebird engine about all changes. Sequences, roles, DDL statements, and so on. And this plugin actually may do whatever it wants with this data. What we call a built-in native Firebird replication is actually a built-in plugin, which is not available as a plugin. It's just compiled statically inside the agent, but it works exactly the same way. It's just a Firebird kind of agent of this CDC interface developed by the Firebird team and linked inside the Firebird engine. So you collect these changes. You may do whatever you want with them, but then finally you need somehow to, for example, if you were considered still replication technology, you need to apply them. Again, Firebird 4 offers public API extensions to apply replication packets. Why? For example, if you may parse these CDC changes, you may transfer actually these buffers into records, inserts, updates, deletes. Actually, all you need to perform changes yourself via the standard API. Why? The replication API is more specific. It's well optimized and works with big blocks, for example, not the record level. The API works at the block level, kind of bulk batch API available in Firebird 4. It doesn't check many permissions. It just requires a single replicator role for your user, and everything becomes allowed for that. Replicated changes are not firing triggers on the replica side. I didn't speak about that yesterday, but it works in the native Firebird replication, or if you use that API yourself. And multiple different optimizations are also possible to just ensure that the changes are being applied really fast and efficient. What you could use this CDC interface for? First of all, if you, for some reason, do not like how Firebird maintains journal files and you want to implement some your kind of journal, it could be, for example, other Firebird database used as a journal file, or just some operating system tools for that. Or you are okay with the journaling, but you want to implement your own transport options. Do not use the Firebird protocol, but instead write something that can email or use some REST API tools to transmit data and so on. Another option is that your Firebird database is used in the OLTP environment, but you also set up some OLAP server. It could be absolutely different software, Vertex, ClickHouse, whatever. Exactly used only for analytics. It has absolutely different format of the database, and native Firebird replication cannot be applied there. But you just parse these changes, convert it to the format which is understandable, but that software, it could be XML, JSON, its own native format, and so on. And use the tools of the import tools of that software to just move your changes there, and then create some analytic reports and so on. Or you may just use these changes to perform some row level audit to detect what changes are really done here, but you do not want to use the standard Firebird journal files. You just write your plugin, it just somehow collects these changes and informs, alarms something if something is really wrong, or just perform really some kind of its own login to analyze later by the security team and so on. Actually, different applications are possible. We are just providing the tool how you could use that. Actually, maybe even something like if you are following the recent interbase features, they had some kind of change views feature when your client application gets notification about changes from the server. Theoretically, the same thing could be done in Firebird using the CDC interface and custom plugin. But it just needs to communicate with your client application somehow. Okay, I'm almost without time, so I have finished. If you have any questions about this presentation, we have 5 minutes, so please, yeah.
Seems to me that if you're replicating across a network, synchronous is not very useful. The moment the network goes down,
yes.
your database is now useless. Your replicated database.
Yes, yes, that's so. Only if you have fast network and really reliable network. Well, nothing is absolutely reliable, of course. But in the case you trust that, or you have multiple synchronous replicas via different networks, for example, you may consider that. Otherwise, I would recommend asynchronous replication. It's more usable, it's more error prone, but just by design it has some lag. Yes?
You talked about force write-off.
Yes.
Combined with the synchronous replication. For a production environment, what are the cons?
The only con here, well, it allows you to recover in the case of your master database somehow gets problems. The really problem here is that with synchronous writes turned off, you start to be afraid not only about hardware changes, but also about operating system crashes. Because the system, file system cache will disappear, changes will not be written, and your primary database gets corrupted or out of sync. So if your server operating system uptime is really long, and you trust that it's not happen any problems with that, it could be an option for you. If it's, for example, well, some of users I know are running, for example, database on Windows Server with some kind of not a really good administration when somebody can just switch off the cable and so on. So the operating system will die immediately without any possibilities to flush the cache, and you will have to switch to the replica every time when it happens. So if your environment is server environment is quite stable, you could consider that. If it's not really stable, your average uptime is just 1 month, for example, then you will be perform a failover every month. As simple as that.
Would it be possible to change what rights depending on the state of the replica? If the replica goes down, what rights is perfect on?
Automatically, you mean? Well, it's not working right now that way, but I will think about that. The problem is that changing the forced writes at run and try time is really not a really robust operation because you know the parallel activity, different connections, and so on. In Super Server, it's a little bit easier, but for Classic, well, it's a little bit more tricky.
It's possible for the application to receive the replica state of the database. Is it read-only? Is it read-write?
Yes, it's all well.
Somehow from context variable, something like that.
Yes, I just don't remember was it committed or not, but at least we have a patch about that, because the original implementation just contained only read-only mode. So, and we had a context variable telling you whether this database in the replica mode or not. In Firebird 4 we have extended that, allowed read-write replicas. I just don't remember whether we applied these changes to this context variable or not, but I will check and we'll commit it anyway, so it will be available in the final release.
The same question about number of replication segments.
It's available as a context variable to get the last, how to say that, current number. So kind of next sequence. So the last generated segment file has its own sequence name, and it's available on the header page, and it's available with the context variable. On the master side, only. For the replica, because it's constantly changing and using different rules, so far it's not available, but well, it should be done some way, I think so. Yes. 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 With barriers turned on by default. X3 and X4 file system has barriers turned on by default, and this is why the difference is so big. If you disable barriers in the mounting options, the difference will be 3 or 4 times, not 10 times.
By the way, may I add, you may Google about barrier. There were several discussions about Firebird databases and using the barrier. And there was some kind of combination of barrier or on, forced write on, and the measurement of the performance.
Yes,
So
we had this test done in some slides of the previous Firebird conferences, I believe so. I have seen some questions from that side, no? Yes?
Can we count on the replication process to remain both forward and backward compatible?
So far, we hope that, yes. Because otherwise it would be impossible to downgrade, for example, a migration downgrade will be impossible. Because the new replication packets will not be understandable by the old replication engine. So we hope to have it, well, of course the replication protocol will evolve in time, but so far we are planning to support at least a few older versions as well, to be able to send data to the older servers too. Well, time is over. I see no any more questions. Thank you for attention. And the next sessions will be split between different rooms, so just choose one you want.